Yesterday, we left off in 4.1. We were on this example 2. We were graphing, right? In example A, what did we decide? We had to take, ouch, that was my ankle. Okay, we had to take that was not a very graceful cha-cha slide then. Okay, we had to take the graph of x squared and do what with it? We had to move it down 5. Because the number was add or subtracting in, we had to move it down 5. Now, over here on B, what do you see?
To the right.
Okay, so this number is added or subtracted inside the parentheses. When we're talking inside the parentheses, we're now talking left or right instead of up or down. So this was an up or down. This is left or right. Which way did you guys say?
Right.
Right 4. Because when we talk left or right, I always say left or right, opposite the sign. And so this is going to be translated right 4 units. So that's what we're going to be doing with our graph here, is we're going to be taking our graph and moving it right 4. Okay, so start setting up your graph.
This is my dominant hand, and this is the one I write with, so.
Okay, so you're going to get caught up here at some point then? Okay, make sure you're following along. Okay, so translating right 4. When I draw my graph, I'm going to have to allow room to move to the right, aren't I? Now, as I do this, on a normal graph, do you remember what your parabola looks like? Did we talked about this yesterday, yes?
The 0, 0, 1,
Yeah.
2, 4.
If I jump back real quick, this is what you have at the bottom of your previous page of notes, right?
Yeah.
This is a basic parabola. And we talked about a basic parabola has points at 0, 0, and then from the vertex you go over 1 up 1, over 2 up 4, right? Okay, so that's your basic parabola there. We're going to use that. And so in a normal case, we normally need to be able to go left 2, right 2, and up 4. But we're also going to have to shift this where? Right 4. So I'm going to add 1, 2, 3, 4 more marks to move it right. Okay, so I have set up that we can go as far as 6 to the right, if you will. If you want some labels, I'll put every other number on there for you. Now, your choice. Do you want to put those original dots on there like I did yesterday? Some of you may still be saying yes at this point, and that's fine. If we put these original dots on here, remember the vertex was at 0, 0, and this is what I would just be doing real lightly in pencil if I'm on paper. Then from 0, 0, we go over 1 up 1, both ways, so left 1 up 1 and right 1 up 1, and over 2 up 4, over 2 up 4 in both directions. That's my original parabola, right? What are we doing with this parabola?
Moving everything to the 4.
Moving everything
Right 4.
right 4. So, as I move everything right 4, my suggestion is we take the vertex and count over 1, 2, 3, 4. That's my suggestion. And so what is that point going to be? That's going to be my vertex. And my vertex is at what ordered pair now?
0, 4.
Reverse that.
4, 0.
4, 0. And I'm throwing this in here because I can't remember. Math Excel might ask you for the vertex sometimes. Maybe not. Maybe I'm imagining things, but they might ask you for it. Now, one option is to move each of these points over 4, right? The other option is from this vertex, do your over 1 up 1 and over 2 up 4. You can also think, let me throw in real quick, where'd my axis of symmetry move to? If my axis of symmetry was here at 0, where is it now?
4.
It moved over to x equals 4, didn't it? And so if you want to draw that axis of symmetry in, on Math Excel you'll have to sometimes you won't. But my axis of symmetry is x equals 4. That shows where my parabola is symmetric there. So, from this vertex, I'm going to go over 1 up 1, over 1 up 1. So I went over 1 up 1 both directions. And go back to my vertex, and I'm going to go over 2 up 4. So that is right 2 up 4, and then I'm also going to go back to my vertex and go left 2 up 4. That happens to land on a previous dot, and that's fine. And remember, as you draw your parabola, attempt, I just totally missed that dot. Well, I kind of missed the other dot now, but attempt to make it more of a U shape, less of a V shape, right? Save the V's for absolute value. Okay, how are we thinking here? We okay with that? Okay. So what about C? Is C easy now? C is f of x equals x squared plus 3.
Translate up 3.
So that plus 3 is at the end, which means it's up or down, direction of the sign. So we are going to translate up 3. If you have not memorized how these work, you're going to have to do that. Are you catching on to that? If you haven't kind of stuck in your brain, okay, how do I know left and right versus up and down? We're still using these. Draw your graph. I'm going to keep my x-axis low since I'm just going up this time. I always need to be able to go left 2 and right 2. Normally I need to be able to go up 4. I'm going to go 3 more than that, right? Because I'm going to have to be able to go an up total of 7. Are you okay if I don't draw the original dots?
Yes.
Because notice I haven't really been using my original dots, have I? And that's my personal preference. If you'd rather draw the original dots in, put in your 0, 0, 1, 1, 2, 4 and the left side. But here's my thing. My vertex is normally at 0, 0. What am I going to do rather than putting my vertex at 0, 0?
Here, put it at 0, 3.
Yeah, we're going to go up 3. And we're going to have a vertex at 0, 3. From that vertex, where do I make the rest of my graph? I'm going to go where?
Up 1, over 1.
Okay. Over 1,
Over 1.
up 1, over 1,
Over.
up 1. So I went left 1, up 1, and I went right 1, up 1.
Over 2, up 4.
And then 2, 4. So go back to your original points. Don't go from your new points. Go back to your original vertex and go over 2, up 4. Over 2, up 4. When you're drawing a parabola for me, I expect to see some of these points in here, right? I don't want just a vertex and, oh, there's my random U. I want the points in there with it. Are we okay with that? Okay, D. What am I doing with D?
Going to the left 1.
Okay, so the plus 1 is in parentheses. Reminder, in parentheses is left or right opposite the sign. So since it's in parentheses and it's a plus 1, we're actually going to say left 1. So translates left 1 unit Really made that really way too wide for just a left one, but that's all right. Normally I need to go left 2 and right 2. I'm going to add one more if I need to be able to go left 1. And I still need to be able to go up 4. What are you doing with your vertex?
Moving it to the left.
We're going to take our vertex from 0, 0, and I'm going to put it here at
Negative 1.
negative 1, 0. Now, I know I didn't on the up-downs. I tend to like to draw my axis of symmetry in here. Where is my axis of symmetry? If my graph moved left 1, it is now at x equals negative 1. Okay. Do you know how to draw the rest of your graph? From the vertex, we go where?
Up 1 over 1.
Okay, 1, 1. So,
1, up 1, over 2, up.
okay, so I got my 1, 1s. I went right 1, up 1. I went left 1, up 1. Go back to your vertex and go
Over 2.
right 2, up 4, and left 2, up 4. Connect your U. We're doing a lot with parabolas this chapter, okay? This is not just a one lesson and done. This whole chapter is about parabolas. The first 2 or 3 lessons were really focused on graphing them and what that can do, okay? So you've got to work on, knowing what's the parabola look like. If it's just a 1x squared, knowing that it's at 0, 0, 1, 1, 2, 4, that we'll keep using. That 0, 0, 1, 1, 2, 4 setup only changes if there's a stretch or a compression. Otherwise, we can always do that. Okay. Do you guys have what you need from this page? A couple people still writing here, so I'll give you a moment. Thank you. Okay. I did this differently today. I have it already loaded on previous page, so I don't have to scroll. And it'll work better for this afternoon. Okay, example 3 type. We are going to start looking at vertex form. Okay, I talked to you yesterday about vertex form. It was introduced at the top that f of x equals a times x minus h squared plus k. So this is your vertex form. And vertex form tells us a lot about the equation. Okay, by just looking at the equation, we know several pieces of information. One of the pieces we're going to know is it's vertex form. Guess what? We know the vertex. The vertex is going to be based off of h and k, which should make sense because h is going to represent how far you go left or right, and k is going to represent how far you go up or down. So the vertex will be right there at hk. We'll also be able to tell the axis of symmetry. Now, we've talked about this, I believe. Maybe I'm confusing my Algebra 1 class. But if you know the vertex is h comma k, then the axis of symmetry is always the first number in the vertex. So it's always x equals whatever that first number in the vertex is. Always, always. Okay. we're going to talk about that the vertex of the parabola is either the maximum or the minimum of the graph. So in other words, if we have a normal right side up parabola, where is the vertex at in this parabola here? It's at the bottom. Is the bottom of something the minimum or the maximum of something? It's a minimum. So in this case, if you have a right side up parabola, your vertex is at the bottom, so your vertex represents a minimum. As opposed to if we have an upside down parabola, where's our vertex? It's at the top, and so it is a maximum. So we're going to be able to tell whether the vertex is a maximum or minimum. Okay? And again, this is all leading down to what we're going to do next. Domain. What do we know about domain? Domain are what kind of values? Domain are the x's. So your x-axis goes left and right. What do we know about parabolas? As they're either opening up or opening downwards, what's a parabola doing? It's going left and right. It's getting wider and wider and wider, isn't it? Okay, that parabola is always going to be going wider and wider and wider. And so what that domain is supposed to say, it got chopped off, but it's supposed to say negative infinity to positive infinity, which means all real numbers. And so anytime you're asked about the domain of a parabola in Algebra 2, the domain is always going to be negative infinity to positive infinity, which means all numbers. Usually you hear us say all real numbers, because we haven't talked about imaginary numbers yet. Kylie did not like what I just said.
I did, because I thought you were serious for a second.
We are going to talk about imaginary numbers. That's like lesson 4.8 or something.
What are imaginary numbers?
We'll talk about them in lesson. It's 4.7, 4.8. It's the end of chapter 4.
Negative zero.
I
So,
want you to picture in your head a number.
yeah.
And that's
So,
imaginary.
yes, up until Algebra 2, everything you've always talked about are real numbers. We get to talk about the imaginary numbers now.
Negative zero.
So, no, like the square root of -1.
Negative zero.
Square roots of negative. So, anyways,
Right,
Negative
is
zero.
Okay.
a new number.
Which one did you say?
I think it's 4.8 is where we talk about it. But 4.7, yeah, complex numbers, 4.8. Okay, but we're in lesson 4.1 today, so let's continue in there.
Okay.
Okay, if domain is x, range is what? Range are your y values. Now, so it's going to be based on the maximum or minimum, and I'll talk you through the range. But the idea of the range is y values, right? So if we have a minimum, then that means the range is all the values above that value. If we have a maximum, that means your range is all the values below that value. And I'll talk you through that in our example here in a moment. Which, we're at that example. So, sorry, I thought I had one more line. Example right here. Here we go. For the equation y equals 3 times x minus 4, quantity squared, minus 2. I think they're asking us, if I recall, it's like 5 questions here. What are the vertex, axis of symmetry, maximum or minimum value, domain, and range? So we've got 5 questions to answer, all based on this equation. Now, what form is this equation in?
Vertex.
This is in vertex form, which if you look, vertex form is a times x minus h squared plus k. And I'm going to write our equation right below it. Our equation is y equals 3 times x minus 4 squared minus 2. Okay, that's our given equation. Let's see. First thing we are asked for is vertex. Now, nice thing is the vertex is given. Glance back up. Where did it say the vertex is? HK. Now, so as we look at H and K, do we see these values? What do we think our vertex is? It is 4, -2. I agree. Now, let's talk about the fact, because I know some of you are probably not quite agreeing with me. On the K value, the number down here is a -2, so we used -2. That's because it's plus K. On the H value, it said -H here, and this says -4. So we just use the 4. So the trick is going to be, it's always going to be the opposite sign of the H value. Does this sound familiar? The opposite sign of what's in the parentheses, and the sign of what's outside the parentheses. If you will, real quick, let me correlate it this way in case it helps some of you. Where does this -4 tell my parabola to go? The -4 in the parentheses would tell me to go where?
Left or right?
That was supposed to be an easy one. That wasn't so easy. Right 4? In the parentheses, left or right, opposite the sign. Right? So right 4, what's the -2 tell me to do? That's down 2. I should have started there.
Yeah.
Obviously. Sorry about that. I went in the wrong order. Now, think about this. Does right 4 down 2, does that match with a vertex of 4, -2?
Yeah.
Okay, so that's another way to think about this. Okay, so vertex. Next thing we need, axis of symmetry. Well, if you know your vertex, you know your axis of symmetry. Axis of symmetry is always what? Your first number from the vertex, so your x value. So in this case, my axis of symmetry is going to be x equals 4. Do me a favor, don't ever just write down 4. Always put x equals 4. Your axis of symmetry is an equation of a line. It's a vertical line, so it's not just a number. It is an equation. So realize here, let me go back to a different color, that first of all, these are my H and K values, right? This 4 will always match. It's not coincidence. It always matches. Okay. What else? What do I need to know? I want to know, is the vertex a maximum or a minimum? And we need to talk about what that value is. So, here, wait, let me, reminder, this is x equals h here. Okay, so, if it's a minimum, that means this parabola opens upward. It faces up, right? If it's a maximum, that means my parabola is upside down. What about our given parabola here? Do we know? What do you think, Lorna?
It's a minimum
Why is it a minimum?
because the 3 is positive. If it was negative, it'd be maximum, but it's positive, so that's the minimum.
Okay. You remember we talked yesterday? If it's y equals a positive x squared, it opens, it's a normal parabola, opens up. If it's y equals negative x squared, it's an upside down parabola, right? So, what you've got to know right here, this 3 is positive. Because this 3 is positive, that means my parabola is going to open up. That means my parabola looks like that, right? If my parabola opens up and looks like that, where is my vertex? It is at the bottom, which makes it a minimum. Now, before we move on, They want to know the minimum value. So they want to know the max or min value. In this case, it's a minimum. So we want to know how low does that parabola go. Since it's a minimum, how low does it go, Kylie?
-2.
What was it?
-2.
-2. Because what's our vertex do? Our vertex goes right 4 and down 2. That is the lowest spot in our parabola. So our minimum value is -2. Now, what's the connection you can make? It is always the y value. Okay, it's not just by chance, it's always going to be that. So your y value, what I had written in my notes is it's my k value. However, if you'd rather think y value, k value, y value, whichever way your brain works. Okay? Okay, almost there. Almost there. Max or min value. Domain. Oof, I'm running out of room. I still got to do range after this. Okay. What about the domain? Everyone should be able to answer this if you can read. Negative infinity, positive infinity? What do we talk about? Domain, your parabola is always going wider and wider. It's always using more and more x values. Okay, it doesn't stop. And so my domain is negative infinity, positive infinity, or all real numbers. I don't remember how they'll do it in Math Excel other than I think it's a multiple choice type thing. But I think they'll just maybe say all real numbers, but they might say negative infinity or positive infinity. I'm fine either way. My guess is they're going to just say all real numbers, but I don't remember. Okay, guys. We have one more question. And that is your range. Now, range are what kind of values? They are y values, right? Now, in this case, I had a minimum, right? I had a minimum at what number? -2. So that means the lowest point of my parabola is here at -2. If the lowest point of my parabola is here at -2, where are the rest of my y values?
Anything above -2.
Anything above -2. So what symbol can we use to express anything above -2? Greater than or equal to -2. So my range is y greater than or equal to -2. Now, my range will always use y. The greater than or less than will depend, is it a min or a max? If it's a minimum, it's going to be greater than. If it's a maximum, it's going to have to be less than. And is it a coincidence we use -2?
I think no.
No. It's always going to match up with whatever your min or max value was. Again, not coincidence. Are we getting it?
Yes.
I took a long time explaining that one, right? There was a lot there. Top of the next page is another one just like it. Can we go a little quicker this time, I'm guessing? I would like to think so. Do we have what we need off of this page? Okay. Same 5 questions. Vertex, axis of symmetry, min or max value, domain, and range. So, I'm going to write my vertex form again, which is y equals a times x minus h squared plus k. And my equation this time is y equals -2 times x plus 1 squared plus 4. Okay, we need to start by talking about vertex.
Negative 1, 4.
Negative 1, 4.
Yeah.
You go opposite the H sign.
Okay. So, and if we look at this, I would like to think it makes sense. Plus 1 in the parentheses tells me to go which direction? That tells me to go left 1. Plus 4 at the end tells me to go
Up 4.
up 4. Okay. And it's also, your vertex is always your H and K value, right? It's always those two numbers. So I agree. Vertex of negative 1 and 4. Are we okay with that? Okay. After the vertex, you're asked about the axis of symmetry. It's always x equals a number. If you look back on the previous page, it says x equals h, right?
X equals negative.
The connection I drew last time is those numbers do match. The x value in your vertex is your axis of symmetry. So x equals negative 1. What do we do next? Min or max? So all I can write is an m there until we decide. What do you know about this parabola? What's this negative 2 out front tell me?
Thingy. The maximum.
Yeah. Because this number, because our a value is negative, that tells me that this opens downward. So, there's your visual. So the negative tells me it opens downward. So where's my vertex? A maximum. Now, that'll get you partial credit in my book. Math Excel, maybe, maybe not, but a maximum of what? So the question is, how high does this parabola go?
4.
And it goes to a height of 4 because my parabola goes up 4. It is also always the y value from your vertex, right? I don't know if these dotted lines help or confuse. If you don't want the dotted lines, don't put them in. But I'm just trying to show you the connection when you look later. Domain. You don't have to know anything about this problem other than it's a parabola. Domain is all real numbers. Okay, that parabola is getting wider and wider. Range. Okay, so range always uses the variable y. What's the y value we're talking about here?
4.
That 4 from above, right? Just going to take it right through the middle there. Now, the values, are they bigger than 4 or smaller than 4? And if 4 is a maximum, it's the highest point, so the rest of my values need to be less than or equal to.
So these, no matter what, it's going to be less than or equal to, right?
No, because last one was greater than or equal to.
Well, I'm not like.
So what it's going to come down to is if it's a maximum, you're always going to use less than or equal to. If it's a minimum, you're always going to use greater than or equal to. Okay? Okay. I have one more topic here. You guys have what you need off of this page? I mean, right here you've got, what, 5 answers? So lots of answers there. And I believe in Math Excel, it'll be like a 5-part problem or whatever where you have, you have to answer all 5 parts. So, okay, the bottom of the page. One last topic. See if we can get through it. Example 4, vertex form. We've talked about vertex form today, right? F of x equals a times x minus h squared plus k. Given a vertex and another random ordered pair, we're being asked to write the equation. Okay, so let me start by writing out what is vertex form. Vertex form, it's given up above, right? Instead of f of x, I'm going to say y equals a times x minus h squared plus k. When we're given the vertex, what are we given?
H and K.
If you go back to that previous page, right, the vertex right here is h and k. Well, in order to write this equation, you have to know h, k, and a. That's the trick, is that we have to know h, k, and a. So if I rewrite it right now, I know y equals, I don't know a yet, but I know x minus, what's h? 3, quantity squared, plus k, which is plus 7. So that's what I know right now. What's the problem? I don't know a. Now, what did they give me here? They gave me an extra point. And that's what we're going to have to use to find a. What do you know about an ordered pair? What numbers are in an ordered pair? What values? X and Y. Well, if you look right here, we have X and Y. We already have H and K filled in. We can use this to find A. Okay, so vertex form, y equals a times x minus h squared plus k. So I'm going to fill in x and y for the moment to help me find a. So in place of y, I'm going to say 4. A is what I'm trying to find, so it's going to stay a. X for the moment is going to be 9. Minus h is 3, quantity squared, plus k is plus 7. You have an equation to solve for a. Now, you guys say PEMDAS, I say Aunt Sally. What's my Aunt Sally tell me to start? Exponent, or parentheses. 9 minus 3 is? 6. So then I'm going to have 4 equals a times 6 squared. 6 squared is 36. Now, notice how I'm going to write this. This is a times 36. So I'm going to say 36a plus 7. And that's important that you think about that's 36a plus 7, because that determines my next step. Some of you are adding 36 and 7. I'm going to say, whoa, back up. You can't add 36 and 7 because 36 is attached to a. What do I have to do? Subtract 7. Subtract 7. 4 minus 7 is negative 3 equals 36a. If it's 36 times a, divide by 36. And I have a is negative 3 over 36.
Negative 1, 6. That's not
Check again. Negative 1, 12
112.
is my a value. Now, so how do I write my answer? Yep, you guys are got it. Y equals A is negative 1/12 now, times x minus 3 squared plus 7. That's what I'm wanting for a final answer there. Yes, A came out to be a fraction. Good news is you didn't have to do anything with that fraction after you got done, right? So no stress there that it came out as a fraction, and now what do I do with it? Now, I know I don't have time to go through B. The only difference on B, it's instead of them stating the ordered pairs, they gave you a graph. That doesn't make it impossible, folks. They gave you a vertex here, right? So, they gave me a vertex. You can tell what that is. That vertex is, how about 4, 2? So they gave me a vertex. That is my H and K. They also gave me another point. Now, they actually gave me 2 points. Do you have to use both? No, pick one. If we use this one right here, there's the negative 2, 2, negative 2. And those are x and y values. Could you now do this problem just like A?
Yes.
Okay. You've got your notes, your homework. I can't write it down there, but lesson 4.1 in Math Excel. Get it done for tomorrow, please. Okay?